In this question, we are given f, g, and h, and we are required to find the gradient of the normal. So what we can do here is to start from the original function that are given. So it's given that h of x is equal to the composition of f and g, whereby f takes the results of g. So you apply g first before f. Now, we can go ahead and find, now this is a composite function, which implies that if you want to find the gradient function, or if we want to find the gradient of this curve at x equals to 3, then we have to apply chain rule. So h dash x will be equal to, when you apply chain rule, you first of all find the derivative of the outside multiplied by the derivative of the inside. So if we want to find the gradient of this function at x is equals to 3, that will be equal to f dash g of 3 multiplied by g dash 3. So we plug, we are it's given that the value of g at 3 7, so that will mean that f dash 7 multiplied by the gradient of g at 3 is 4, so that will be 4, and the gradient of f at 7 is -5, so this will be -5 multiplied by 4, which is -20. So what does this mean? This implies that the gradient of the tangent at x is equals to 3 is -20. So gradient of the tangent at x is equals to 3 is -20. So the gradient of the normal at x is equals to 3 will be the negative reciprocal of the negative reciprocal of this, which is 1 over -20, and that will be 1 over 20. So basically, the gradient of the normal at x equals to 3 is 1 over 20. Number 15, again, the table gives us the value of f and g and the corresponding derivatives at 1 and 8. Now, h of x is a product of f and g. The first question, they want us to find h of 1. So for part A, h of 1 will just be f of 1 multiplied by g of 1, and f of 1 is 2, and g of 1 is 9, which will be 18. Now for part B, they want us to find the gradient of h at 8. Now h is a product of two functions, so to find the gradient of h, we have to apply product rule, and that will be f of x multiplied by derivative of g plus g of x multiplied by derivative of f. So h, the gradient of h at 8 will be f of 8 multiplied by the gradient of g at 8 plus g of 8 multiply the gradient of f at 8. So f of 8 is 4. The gradient of g at 8 is 5. G of 8 is 2. the gradient of f at 8 is negative 3. So this will be equal to 20 minus 6, which is just 14. And that's it. For number 16, we have f of x is equals to the quotient of g and f. Therefore, it looks like you're going to apply quotient rule because you want to find the equation of the normal to the graph of f at x equals to 2. So let's first of all find the gradient of f, or the gradient function. So we can start by finding we actually, yeah, the easiest part that we can start with here is by finding the value of y at x equals to 2, because we need the equation here. We need the corresponding y coordinate. So f of 2 will be equal to g of 2 over h of 2, and that will be equal to 18 over 6, which is 3. So what this means that the point of tangency, or where the tangent occurs, uh, the point of tangency is 2, 3. So this is where the if the tangent occurs at 2, 3, then means the normal occurs at the same point. So we'll use this to find the equation of the line. But anyway, let's go back ahead and find the gradient of the gradient function, and use the gradient function to find the gradient of this curve at x equals to 2. So the gradient function f dash x will be, now we apply quotient rule, so that will be h of x multiplied by the gradient of g at x minus g of x multiplied by um, the gradient of h of x over h of x squared. Right. So which means the gradient of f at 2, the point of tangency, will be equal to h of 2 multiplied by the gradient of g at 2 minus g of 2 multiplied by the gradient of h at 2 over h of 2 squared. So if you plug in this value, h of 2, it's given in the question, that is 6. So 6 multiplied by g dash 2 is 5 minus g of 2 is 18 multiplied by h dash 2 is 2 over h of 2 is 6 squared. So this will be 30 minus 36 over 36, which is equal to negative 6 over 36, which is negative a sixth. So what this means is that gradient of the tangent at x equals to 2 is negative 1 over 6. So gradient of tangent at x is equals to 2 is negative a sixth. So the gradient of the normal the gradient of the normal at x is equals to 2 will be the negative reciprocal of that, which will just be 6. And then if you apply the points law formula, because what we want is the gradient of the equation of the normal, so y minus y1, which is 3, will be equal to m, which is 6 into x minus 2. So y minus 3 will be equal to 6x minus 12, and therefore y will be equal to 6x minus 12 plus 3. Y will be equal to 6x minus 9. And that will be the required solution.